Hi everyone, welcome back. Today we are going to talk about how to write a Vhdl code using Vhdl 2018. So if you are new here, make sure you hit the subscription button and like the video as well. So we are going to write a Vhdl code for an AND gate with 2 inputs and 1 output. So let's get started. So firstly we need to open our Vhdl. I'm using Vhdl 2018.1. we click on it. Right, so if you have an already prepared project, you can click open project. You can also click an example project. You can also create a new project. Since we don't have an open project and we are going to have a step-by-step creation of the project, we're gonna click create project. Then it will tell you this wizard will guide you to the creation of a new project. To create a Vhdl project, you will need to provide a name and a location for your project files. Next, you will specify the type of flow you will be working with. Finally, you will specify your project sources and choose a default path. So we're gonna click next, and you're gonna name your project. Let's name it and get. So we'll put an underscore. So and get, we want it to be a 4-bit operation, so we can name it 4-bit. This is the project location on my PC, and then we click next. Already exists, so this already exists in my PC, so we're gonna name it just and get. We click next. Specify the type of project. We need an RTL project, which says that you'll be able to add sources, create block designs with the IP integrator, generate IP, run RTL analysis, synthesis, implementation, design, planning, and analysis. So at the moment we do not specify the sources at this time, so this box must be checked, and then you click next. So we have a range of parts depending on the physical board or part which you have. We have a variety of them, as you can see, but at the moment what I do have is a board, and this board we have a variety of boards which are here, which are zinc board, ultra scale evaluation board, this one. But the one which I possess is the Zybo board, the Z10, which is this one. Each board has got a manual which you will need to know how to read it through, how to connect or port map what you have on the software onto the hardware, because the whole purpose of writing a Vhdl code is to have a software which will be integrated into a hardware through this board. So we are using the Zybo Z10, which is in the 7000 series of the Zybo family. So we click next, we click finish. Now we have our project open, we have our project manager, the settings where we add sources, the language tablet, IP catalog, IP integrator, where we create a block design of our choice. We have a simulation option where we run the simulation. We have an RTL analysis where we can open an elaborated design. We have a synthesis, we have an implementation, we have a program debugging or generation bitstream. So firstly, for us to have what we have designed as a software here to be implemented on the hardware, we need to add sources, where we add the design sources, a constraint file, and simulation sources. After adding this, for us to implement it on a hardware, which is the Zybo Z710, which is part of the 7000 series, we need to run the simulation, run the synthesis, run implementation on the board, provided we did correct port mapping, which is specific to each project. We need to generate bitstream and then open a hardware manager. Then we can see the results on the hardware. But on this video, we are going to focus mainly on designing the sources and the simulation sources. So the source, when you're told to design the source, this one is the Vhdl code which you are going to write, and the simulation sources is the test bench. So we are going to write this code using Vhdl. You can use Verilog depending on your project type, but I'm gonna use a Vhdl code. So we click Vhdl, we click apply, we click OK. As you can see, this is our project name. We named it and get the project location, the product family, which is the 7000 series of the Zinc. I will talk about the Zinc architecture in the next videos, so please tune in or subscribe so that you won't miss any part of the embedded systems. So our top module name is not defined. The target language is Vhdl. The simulator language, we can put Vhdl. Apply. Okay. Now we have a project name, we have a project location, we have the product family, the project part, which is the specific name of the hardware which we are using. The target language is Vhdl and the simulator language is Vhdl. Right. So we need to design sources. We click on design sources, we click the plus sign, we check or mark add or create design sources, we click next, we create a file. So when you create a file type, it will write the language which you are using. What are we using? Or the file type we are using Vhdl. So the file name, we are creating an end get. So if you put a space, it won't be able to work. So what you need to put is an underscore if you want to combine words, and then file location you can choose wherever you want to. It doesn't affect the project running, or it doesn't have an overall effect. And then we click finish. So whenever we are writing a code or designing a source, we need to port map. How many inputs do we have? How many outputs do we have? Since we are creating an AND get, we have two inputs, A and B. We have input A, we have input B. This is the direction of the port, which is an input. Now we need to put an output, which will be C. So we have to change the direction to say that it is an output. But if that output is going to be an input in the next system, then you have to put in out, which means A and B will be inputs, giving C as an output, which will act as an input on another system. So since we only have 3 ports, A and B, which are inputs, and C, which is an output, we create output input C. This is the bus. This is the most significant bit. This is the least significant bit, so we are not interested in that at the moment, so we click OK. Now we've designed our source. It has been updated. We double click it, and then we can see here, this is the Vhdl code. These ones don't matter. These ones in gray don't matter. So the overall code, for you all not to be confused, I'm gonna remove what is written in gray. So I just select them and cut them. So I'm gonna let my code start at line number 1. So now we have designed the source of the project. This is the source. Now we need to create a simulation source, but this project, we need to know this AND gate, is it operating a 2-bit system? Is it operating a 3-bit system? Is it operating a 4-bit system, 8-bit system, a 16-bit system? That's what we want to know. So if we say that the AND gate is operating a 4-bit system, what we do here, to avoid any errors arising in the project, we must edit our library. So we include the library IEE, use IEEE standard logic OR, and we can use IEEE numeric standard OR. So we're gonna add another source. Use IEEE dot numeric standard. We'll put an underscore numeric standard dot OR, and then we put a semicolon here. Now our code is no longer underlined. So after declaring the libraries, well, the libraries are pre-written codes which will be used here. These are pre-written codes which we must include. So after this, the second step is defining the entity and port mapping. So the entity of the AND gate is we port map A. A is in standard logic vector because it's undefined yet, so we need to put a vector like this. If we are operating a 4-bit, we put 3 down to 0 to specify that this code is running in a 4-bit system. If you are operating a 16-bit system, it's 15 down to 0 because 0 is being counted as well. If we are operating an 8-bit system, it's 7 down to 0 for all inputs. The output then depend what you are having, to be honest, but for inputs, 4-bit system 3 down to 0, 8-bit system 7 down to 0, 16-bit system 15 down to 0. So for this AND gate, we are operating a 4-bit system, which is 3 down to 0. So in our brackets, we put 3 space down to, in small letters, 0. We close the brackets. So we just copy and paste here and put on the input B, but we have to put a standard logic vector as well, 3 down to 0. And our output from the question, our output, this one we normally put here for it to be logical. Here is an output, C is an output of AND gate, so it is also in standard logic vector. Since the inputs are in standard logic vector, we can put capital letters or small letters, but it has to be uniform vector. This one will give us 8-bit system, so it's 7 down to 0. Right, then we end the AND gate entity. Then after designing the entity, we design the architecture. So the architecture behavioral, we are considering the behavioral of the AND gate is, so the architecture defines how the system works. It defines how the system works. So it defines how are we going to get C from A and B. So that's what I'm going to write. So we write C is an output of the standard logic vector you may unassign it or sign it. It depends on what you want. We can give a number. We signed A. Since it is an AND gate, AND means multiplication, we multiply this by a signed B. So for A and B, we need to put curly brackets to show that these are numerical values which we are writing, and then we close the bracket and then we put a semicolon, not semicolon but this one, to end our code. So as you can see here, this bracket closes with this bracket, and this bracket closes with this bracket. So we're gonna remove begin. the space as well. You can put an assigned. Then if you are there to debug it, then you can debug it. You can actually see the errors which we have made here, but overall this is how you write your Vhdl code. This is how you design the sources. So I'm gonna cut out the video because my PC is running out of battery, so I'm gonna continue on the next video. Thank you for watching. Goodbye.